All right, guys, we're going to go ahead and do the basic probability notes. This is going to include most of all of the reminder of all the basic information about probability that we did, plus binomial and geometric. Now, random variables is also included in this unit, but I've made a separate section for that off of notes, in a separate section of notes. Okay? This video will help you to do the multiple choice sections A and C. Okay? The multiple choice section B is random variables, and you would be better served to watch the second set of notes video before you do multiple choice question set B on the progress checks. Okay. So here we go with our basic probability. Randomness is, you get things that are random. It can't be anticipated immediately, but in the long term, it actually is predictable. Law of large numbers, in the long run, we have that theoretical probability. Okay, so it's the successes out of the total. We know that, and it's always a number between 0 and 1. Sample space is all the possible outcomes, so just listing all of the various items that can happen there. All right, so let's remember some vocabulary. Disjoint. Also, I have seen it referred to as mutually exclusive. Okay, those are completely separate from each other. No overlap. Okay, no outcomes in common. If this person eats all the green M&Ms and this person eats all the red M&Ms, then they ate nothing in common. Okay, disjoint events. And so the probability of their intersection, the probability of it happening at the same time, is 0. All right. If events are in disjoint, then it's easy to add. You could just add this one's probability plus this one's probability. Okay? Because there's no overlap that could get counted twice. All right. So if they are not disjoint, then you have to use this general addition rule, which I'll show you in a minute. All right, next, independent. Very important. So if events are independent, then the fact that one thing has happened does not change the probability of the other. Okay. And if that is the case, they have nothing to do with each other. The proportion of home games that you win at, or the proportion of games that you play at home. 45% of the games that you play at home. Okay? And then the proportion of games that you win at home there's 26%. So overall, what proportion of games do you win? Well, the 45% at home times that 26% or whatever that you win at home. The games at home times the ones you win at home will give you the overall proportion you win. Just multiply. Okay, remember the complement is 1 minus the probability of an event. Okay, now let's recall this given that situation. The probability of one thing, so this is whenever we have conditional situation. We don't have everything, or we don't know that they're independent. So we know that if we said, what's the probability of one thing given that the other has occurred? Here's how it would be written. Probability of A given that B has occurred. All right, now, events A are independent, so you can determine if items are independent. And remember, that's the fact that one thing has happened has not changed the probability of the other. So you could actually compute this, and this is the mathematical process you have to go to check for independence. Right here. You would compute probability of A given that B has happened. And if the fact that B has happened does not change that probability of A, then, if this on the right-hand side equals the overall probability of A, then those events are independent. That means the fact that B has happened did not change the probability of A. Okay? All right. Let's remember that if we have joint probability, then that's the intersection. That's that overlap. Two things are happening at the same time. All right. And here's just a reminder of disjoint, that mathematically those events If they are disjoint, then they are the probability of them happening at the same time is 0. All right. Now, this general multiplication rule is on the formula chart, and we'll look at that formula chart here in a minute. Okay? So that is that. Never mind. If events are not independent, then you would multiply one of them times the other one. Okay, probability of A times B given A. We'll just have to get into that with actual problems. But this one might be a little easier to understand, this general addition rule. Probability of A plus probability. So you're add all the A plus all the B. But let's think about this in terms of a Venn diagram. If we added all of the A probability plus all of this B probability, okay, then we have something in the middle that got double counted. That intersection got double counted, so we have to take away that double counted. All right, next. Here's just a reminder of talking about or. If you want this or that, that also includes both, okay? And if you want this to happen and that to happen at the same time, here's how that is notated, okay? So you can see the or has this union notation, and the and has this symbol here that indicates the intersection. Now, in order to compute these probabilities for the addition problems, you say, are these disjoint? Do I have overlap or not? Okay, if they are disjoint, then you can just add them like normal. Sweet, no problem. This probability plus this probability, add together. If there is overlap, then that's when you have to be careful. You add the A's plus the B's minus the intersection that gets double counted. Okay? And a reminder that the special property for disjoint is that that intersection, probability of A and B, if they are disjoint, then the probability right here in the middle, that's 0. Okay. All right, now let's take a look over here at the intersection problems. Are they independent of each other? And you might have to go ahead and check that. In fact, here's a way that you would check it. Probability of A would be the same as A given that B has happened. All right, if they are independent, awesome. You can just multiply those probabilities together. If they are not independent, then you have to do the probability of A, okay? But if A's happened, then you would multiply it by the probability of A given that B has happened. This occurs when you, for example, if you don't have replacement. If you take out one person, or you take out a green marble from the bag and then you do not replace it. So what's the probability that you get a green marble and a red marble? Or what's the probability you get a green marble and then another green marble? Do the probability of a green marble and then times the probability of a green marble given that you've already gotten one. So that probability goes down and changes without replace. So we'd have probability changing. All right, now let's take a look at the formula chart section of probability on what's on the formula chart that you have given to you. So here is that general addition formula right here. Okay. Here is also how you compute the probability of A given B. Remember, out of all of the A section, you put the overlap, the intersection of A and B on top. Okay, the most common mistake I see here is people will go, oh, I'm going to put all the B section on the top and then all of the A section on the top. B on bottom, A on top. No, that's not true. What goes on top is probability of A and B. The intersection of A and B is on top. All right. Now, we can talk about some things here in this formula. I'll later talk to you about the binomial stuff and the geometric. Okay. Now, and I've seen these problems come up. If you are asked the number of items, not the probability. But if there's 25% chance and there's 100 items, what's the number of items there are? Okay, how many do you expect? Remember, the mean is how many do you expect? The expected value is the mean. Expected value is the mean. Binomial is n times p. Geometric is 1 over p. I think I actually in the song say it. Geometric 1 over p. Binomial n times p. Okay, so on average, how many number of items do you expect? Okay. And then with these standard deviations, so this is the number of items, the variability of how many items you expect to happen. And here's that. All right. Now, you might add this to your formula chart that you print out for yourself, okay? Because remember this rule for independence. You are checking the probability of A and seeing if it is the same amount that A given B, okay? All right. Now, a couple other strategies, Venn diagrams and tree diagrams. So I love Venn diagrams because they're a visual, and I'm always all about visual. So I typically gravitate towards when I get all these things and I see there's overlap, I generally put it in a Venn diagram instead of going through the formulas. So here's an example that we could study with going through the formulas, or writing it as a drawing it as a Venn diagram and visualizing things that way. Okay. So remember the pool or garage, formula-wise, that says the probability of the pool plus the probability of the garage minus the overlap, okay? Minus the intersection of pool and garage. All right, so that could be done formula-wise that way. But over here, I actually drew the Venn diagram, and so I wanted to remind you that when you do that, you have this situation going on. So remember, if we say 17% have both, that's what you want to put on your Venn diagram first. 17% have both. And then from there, what you have to do is say, oh, the garage total is 64%. Okay? Garage total is 64%. Well, look, I already have this 17% in my circle, so the remainder is that 47%. Okay? So 47% have garage only. All right? And the same thing for the swimming pool. 17% are already in the swimming pool circle, so to complete the remainder of the 21%, 4% have pool only, or pool with no garage. And so there's that there. All right, because then you could add these up, the 0.47 plus the 0.17 plus the 0.04, and you get 0.68. And then with that, you could see who's out here, who has neither. Okay, and that would be 1 minus that 0.68. All right, Venn diagram. Next is another technique, very important when you start getting told multiple conditions. If this happens, then it's this probability. Oh, but if this happens, then it's this probability. Oh, but there's even more. If this happens, then it's this probability. Okay, that's like when you start getting all these if this, then that statements. If this, then that. But if this, then that, then you need to think, oh, I should organize this in a tree diagram. So here we go. This is the one where Leah, we're told she leaves on time. Well, if that first flight leaves on time, then, there's a 95% chance her luggage will be there on time or will get there to her connection. 5% chance it won't. Okay, so this is the if her luggage leaves on time, which is 15%. I mean, if her flight leaves on time, which happens only 15% of the time, then here's the rate at which her luggage will get there or not get there. Okay? And then, but the 85% of the time, her first flight's delayed. If it's delayed, then we got 65%, only a 65% chance her luggage gets there and 35% chance her luggage doesn't. All right. Then the ultimate question comes in. Given that her luggage did not arrive. What does that say then about her first flight? Okay, what's the probability then that it was a delayed first flight? So remember, all of the luggage not getting there goes on the bottom. That's the denominator. Out of all the ways that her luggage doesn't get there, what's the delayed part? So here is the luggage not getting there. That's that. Here is the luggage not getting there, and that's that. So luggage not there, but she was on time. Luggage not there, but she was delayed. Okay, so that's the total ways in which her luggage did not get there. Then one of these pieces on the bottom is going to be the numerator, because it has to be which portion? The delayed portion. And so that is that 0.85 times 0.35. And that meant 97.5% chance. Her luggage didn't get there. There's probably a 97.5% chance that her first flight was delayed. Okay? All right. Now, here let's talk about this geometric and binomial stuff. Okay? And this you can just, refer back to as you're doing problems. Unfortunately, so much of probability is just practice, 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 practice. I can't write out all of the different wordings that you will encounter. Therefore, I just have this thinking map of this diagram of all these different things you could encounter, but then you have got to practice. So I have, we'll talk about this in a second, but I also, you can only get this with practice. So I put basic probability, which includes the geometric and binomial practice, in this notes section. So you'll find another link to that. It has some basic problems and the key of me working it out. So it lists about 2 or 3 pages of basic problems and then 2 or 3 pages of me working it out so you can self-check yourself before you start doing the next assignment. Okay? All right, here we go. Okay, remember geometric is when you go until a success. So then the order of items get defined, So how many do what's the probability that you don't get a Japanese car until the 5th car that you check out? The 5th car to the stop sign. Okay? So the exact place of that first success. The first 4 are not Japanese, and the 5th one is Japanese. All right. Now, you could also compute that as geometric PDF. And so that would be, you would go geometric PDF. These are under the place where norm CDF and norm CDF is. So you go in your calculator to that menu. So geometric, what's the exact place of the first success? If I said 56% of cars are Japanese, then I would say, and then we don't want one until the 5th spot. No Japanese until this 5th spot. So geometric PDF of, let's see, I want that 56% to occur for the first time in that 5th spot. Okay? All right, if I say, what's the probability that you see a Japanese on or before the 5th spot? Then that would be accumulating a success in the 1st or the 2nd or the 3rd or the 4th or the 5th. So that would be a geometric CDF of that 0.56 in the 5th spot. And so that's going to accumulate all of those ones below, or 5 and below. But what happens if you want, what's the probability you find the first success after the 5th spot? So you have to go 5 spots, and then the success happens after that sometime. A couple of ways you can think of this. You can do 1 minus this lower part. You could do 1 minus this here. Also, if you think about it this way, the first success happens after the 5th spot. Well, then that just means all the first 5 are failures. So if you computed 1 minus this number here, it would also be the same thing as 0.44, all the first 5 being failures. Okay? Anyway, so that's a lot to just like say to you out there. You've just got to get into a problem and practice it. Remember that these are on your formula chart. Expected value is the mean. So how many cars do you expect to have to look at until you find one that is Japanese? So that would be the 1 over the 0.56. Okay? And with what standard deviation? And then you do that formula there. All right, let's talk about binomial. Binomial is different. It's not, hey, let's go until this happens. What's the probability you go this many until you find this success? No. Binomial says, hey, look at 10 cars. What's the probability that exactly 3 of them are Japanese? Okay, so that is a set number. Hey, look at 10 cars. Not go until you have a success. Okay, how many successes out of the first number? Now, if I say, what's probability? Exactly 3. That's exactly 3 sprinkled anywhere amongst those 10. So you can have lots of different combinations. So that's a binomial PDF, and you would say binomial PDF of out of 10, and we have 56% probability of Japanese, and then I want exactly 3 of them to be Japanese. Okay, you do binomial PDF of that right there. Now, what happens if you want less than 3 or at most 3? Then you want to accumulate that bottom section. Okay, so it would look like this here. Now keep in mind that when you do this accumulating, it's up to and including that third number. So if I want to have 3 or less successes, then I would do binomial CDF of that 10, 0.56, 3. If I want to say out of 10, I want at least 3 successes, then I want the top part. Remember our calculator, if you have the older, unless you have the newer calculators, operating systems that can compute the upper probability. But most of the times our calculator can just compute the lower probability. So we have to do 1 minus the bottom part that we do not want. So let's say I want at least 3 successes. Then that means I want 3 up to 10 successes. I want 3 up to 10. So then that means that I need to take off the accumulation binomial CDF of the 0 successes, 1 successes, and 2 successes. So I would do 1 minus this bin CDF, the accumulation of 10.56, and then this number is what you want to take off. And since I want at least 3, I want 3 and more, so I want to take off 2 and below. Okay, so there's just a little basic introduction. You have to practice, practice, practice. So, again, in your Canvas, I can go ahead and show you this. If you look in your Canvas for this week, then here you'll have in this section with your where the notes are for this week. We're going to have down here, let's see. Okay, so here's that page where you found this video. Okay, but then below it says, want to see this in action? Learn and self-check. Try this. And here's that basic probability key practice. So I've got 3 pages, or 3 or 4 pages, it looks like. 4 pages of practice, but you could look immediately at the answer. I even include how I put it in the calculator so that you could check yourself and see. Okay. Oh, and by the way, don't forget that probability of at least 1. It's 1 minus the probability of none. So the probability that none, 1 minus the probability that none are successes. All right. Also, it's worth noting that the next assignment that you actually do complete, here's the first assignment you complete. Looky here. I have each one of the the problems explained with another video. So look, I have 20 short videos explaining every single one of those problems so that you can have immediate feedback and immediate practice. Okay? All right, so there is your first part of Unit 4 on basic probability and binomial and geometric. Then there will be a separate video for the random variables portion.